this video is for you. If you are writing organic chemistry, irrespective of the examination you may be writing, irrespective of the particular exams, maybe JAMB or 111 student exams or WIC or NECO. So far, it is organic chemistry and it is objective. Please, this video is for you. All right, I will be showing top 30 questions you could likely come across in your exam. Okay, now, but before I show you, please, I need to explain something very important for you. Before I show you, I want to explain something quickly, very important, and I want to show you something trick, simple way. You have to memorize and you have to take notes before I start solving. All right, let me explain something like hydrocarbons. I want to explain hydrocarbons to you in this class. So let me explain hydrocarbon. When you talk about hydrocarbon, we simply refer to as hydrogen and carbon. You see, from here to here, hydro, it means this hydro means hydrogen and carbon. So we are talking about a family of hydrogen and carbons that contains only hydrogen and carbon. Give me examples of hydrocarbon. You know your cooking gas, the gas you use to cook food at home, okay, it's mainly butane, although it's a combination of propane and butane, but it's mainly butane, so we usually call it butane, and the formula is C4H10. C4H10. You see that it contains 4 carbons and 10 hydrogen. Our concern here is that it's a combination of only carbon and hydrogen. So even your petrol, C8H18, the carbon there is what is 8, while the hydrogen there is what is 18, but it's a combination of hydrogen and carbon. So I just want to explain quickly what hydrocarbon is for us. Now, when you talk about hydrocarbon, as I've explained earlier, it's a combination of hydrogen and carbon. This hydrocarbon can be further classified into 2. We have what we refer to as the aliphatic, and we have what we call the aromatic hydrocarbon. When we talk about aromatic hydrocarbons, we are simply talking about benzene. You know benzene, okay? Benzene has what? C6H what? 6. You can still see that the carbon is 6 and the hydrogen is 6. It is still hydrocarbon because it contains only carbon and hydrogen. But let's assume you have what we call ethanol. You don't see ethanol is C2H5OH. Is this hydrocarbon? No, because of the presence of this oxygen that is there. Oxygen is not hydrogen and it is not a carbon. So because of this oxygen, it is called non-hydrocarbon. Okay? So when you talk about non-hydrocarbons, we are referring to as something like ethanol, ethanoic acid, and so many other organic compounds like that. Okay? Now, aromatic simply means benzene structure, while aliphatic is further classified into 2. Under this aliphatic, we have what we call acyclic and cyclic. You see, cyclic here means something in a form of a closed chain, something that is closed. You know, actually benzene is closed, but the difference is that, for example, let's assume we have something like this. It is closed. Benzene actually is also closed, but the difference is that, you know, they have the same size, 1 2 3 4 5 6, 1 2 3 4 5 6. Now benzene could have something like this inside. Because of this thing inside, it tells us that it is benzene. When you talk about the cyclic and when you talk about this acyclic, we are simply telling you that, you know what started this acyclic? It started with what? It started with A. Acyclic started with A. So we have 3 major ones that are present here, which we have alkanes, and alkynes. They all started with what? A. So we have, under this, we have what we call the alkanes. The alkanes, you can see that they all started with A. And the alkyne. But this one started with C. It's just like the cycloform of alkanes and the cycloform of alkenes. That is what this is. The cycloform of this particular one, that is what this is, the cycloform of this. So that is cycloalkane. It started with C, right? So it will be cycloalkane, cycloalkane, and cycloalkenes, and cycloalkenes. Okay, what about cycloalkynes? Cycloalkynes is not usually common like that, so we don't used to talk much about the cycloform of these alkynes. Okay, take note of this. There's something important I want to show you here. Now, in an exam, maybe you are writing it in an objective exams, and they ask you that maybe they ask you what's the formula for cycloalkanes, or anyone, they can ask anyone in an exam. Please, this usually comes out in an exam. Please take note of that. All right, the formula of alkane, I usually encourage students that just try to memorize the formula of alkane. When you memorize the formula of alkane, I will derive the rest from this same formula. I will derive it. So let's start. The formula of alkanes says that CnH2n plus 2. Okay, so if I want to get alkenes from alkane, just subtract 2. You know, when you subtract, it becomes what? Plus 2 minus 2 will change to 0. We are left with CnH2n. That is, this will be, alkenes will be CnH2n. But to get alkyne now, let's rewrite the formula of alkane back. Notice the formula of alkane, CnH2n, H2n plus 2. So to get alkyne, you know, when you are dealing with alkenes, you subtracted what? 2. Why for alkyne? You subtract what? 4. So when you subtract 4, you'll be left with, you know, this plus 2 minus 4 will give us what? Minus 2. It will give us minus 2. Therefore, we have CnH2n minus 2. CnH2n minus 2. That is formula for alkynes. And how will you know the one that will come first? Alkanes. If you look at the difference between alkanes, alkene, alkynes, we have that after this K, we have A for alkene. After this K, we have E for alkenes. After this K, we have Y. You understand? That is the only difference. So that is A comes first before E, E followed by what? Y. We have A, E, Y. A comes first, followed by E, followed by Y. Now, you have gotten the formula of alkanes now. Alkenes, alkynes. Now, to get cycloalkanes, now this one too, you are going to apply the same approach here. For cycloalkane, trace, you know, it is the cycloform of alkane. So come to the formula of alkane. Now, in this case, you know, this one is separate, this one is also separate. Come to the formula of alkane, subtract 2 from it again. So this is formula of alkane. This is formula of alkane. Then subtract 2 to get its cycloform. You keep what you usually subtract is what is it called? When you subtract 2, it will be plus 2 minus 2. This will cancel out. You have what? CnH2n. CnH2n. You are surprised that so cycloalkane is having the same formula with alkenes. Cycloalkanes is having the same formula with alkenes. Yes, they used to ask this exam very well that if the alkenes has the same formula with, you could see something like this in your exams. You could see something like this. They could write this. They could write this in options. Please be very careful. They used to ask this a lot in an exam. All right. For alkenes now, you know, it's the cycloform of alkenes. So trace the formula of alkenes. Subtract 2 again. For this one, you subtract 2. For this one, trace it and subtract 2. Now we have CnH2n. Then subtract 2 minus 2. So the formula of this will be CnH2n minus 2. You can't subtract 2 from this 2n because of this n. So are you also surprised that the cycloalkanes is also having the same formula with what? The cycloalkanes is having the same formula with alkynes. Yes, it's the same thing. They have the same formula. This is where most students get confused. They don't used to understand this particular part. Okay. Now another thing I need to explain is that this has single bond, this has double bond, this has triple bond. Cycloalkanes is a cycloform of alkane. It also has single bond like alkene. The cycloalkanes is a cycloform of alkenes. It also has double bond like alkenes. You understand now? All right. Now, the single bond, this and this, they are called saturated compound. The single bond, saturated compound, this and this. That is alkanes and cycloalkanes. you have single bond. So we refer to them as saturated compound. And saturated compound, they undergo one particular reaction which we call substitution reaction. That is, these cycloalkanes and alkanes, they undergo what we call substitution reaction. Take note of that. But you see, alkenes, alkynes, that have two or more bonds, alkenes, alkynes, cycloalkenes, and even benzene sef, benzene have like double bond. They undergo what we refer to as addition reaction. This alkenes undergo addition reaction, alkynes undergo addition reaction, cycloalkenes undergo addition reaction, and aromatic, which is benzene as an example, undergo what refers to as addition reaction. So, but the thing is that benzene is not only addition reaction, it also undergoes substitution reaction. That is one of the uniquenesses of benzene. It also undergo substitution reaction. Take note of that. That is benzene. Okay. All right. Now, let's start to answer our top 30 likely questions you could come across your exams. Please stay tuned. Okay, let's start to be answering those questions. Okay, now you will see, as you can see the question before you. Okay, I don't want to start writing the questions for us not to waste our time, but you can see the question as being displayed. Okay, now me, I'll be checking the question in this textbook. Now you see question number 1 says that the following are members of alkane series except. Now you can see the options given. That was the reason why I explained this. One of the reasons why I explained earlier, it show you the formula of all these alkanes, alkynes, and cycloalkanes and the rest like that. Okay, now the question wants us to identify the one that does not belong to alkane family, and for you to get that, you need to know the formula of alkanes. So the formula of alkane is CnH2n plus 2. Now let's look at option A. We want to identify the one that does not belong to the member. Now, option A, now you see that we have C2H6. Now our N here represents the number of carbons. So let's substitute this inside it. If you substitute this N inside it and you arrive at this, you arrive at this. This shows that it is a member of alkane. But if you substitute your N, by the time you substitute your N inside and you do not arrive at this, this means that this is wrong. So suppose our N is equal to 2. We have what? C2H. 2 times 2 will be what? Plus 2. That will be 6. You still arrive at this. This is a member of alkane. Let's try the second one. C8H what? H18. That is option B. Our N here is what? 8. So let's substitute 8 inside, whether we arrive at this. So we have C8H. 8 times 2 is 16 plus 2, 18. This tells us that this is also a member of alkane. All right, let's try option C. C12H24. So let's replace our N here to be what? To be 12. Whether we get this. So let's substitute. We have C12H. 12 times 2 is what? Is 24 plus 2. That is 26. Here supposed to be 26, not 24. So the correct answer is this. If you try option D, you will arrive at the same thing. Option D is also member of alkane. If you try it using this approach, you will still arrive that it is a member of alkane. Why? Because if you put 15 here and you say 15 times 2, that will be 30 plus 2, that is 32. You can see that option D is correct. It's a member. But the only one that is not a member is this. And that is what? Option C. That is for that. Okay? You can see, let's look at question number 2. It says, the question is asking us for alkanol. Alkanol has a functional group of OH. Why? Because if you could remember when I explained, when I was explaining organic compound, what's it called? Hydrocarbon earlier. And I wrote a formula on the board. I wrote the formula to be C2H5OH. I call this compound to be ethanol. Ethanol is a member of alkanol. It's one of the examples of alkanol. You see that it has OH. So OH here signifies what? The functional group. So the functional group of alkanol is OH. Now, if you look at option A, it doesn't have any OH. Option B has OH. Now, option C has CHO. No, that is not the functional group. It's not HO, it is OH. So option D is wrong, and option C is it has COOH. Although there's hydrogen, but this is a functional group of Alkanoic, not Alkano. It is Alkanoic. It is Alkanoic, okay? Not Alkano. Alkano has a functional group of OH. So the correct answer to that is option B, okay? Now, looking at question number 3. Looking at question number 3, we have the general formula for alkane. First of all, what is alkane? What is alkane and what is alu? This is the formula of alkane, okay? You know, when I said that alkane undergoes substitution reaction. That means when alkane now, for example, let me use one example. That if you react, we have CnH2n plus 2. Suppose you react this alkane. Let's pick one member of alkane. Like for example now, methane. When n is equals to 1, we have CH4. N is equals to 1. 1 times 2 will be what? 2 plus 2, that is 4. So we have CH4. When you react this with chlorine, what happens is that this chlorine here, it represents halogen. Because that alkane, we have alkane be reacting with halogen. That is alkane and halogen. So this is alkane, this is halogen. So when you react them together, what will happen is that, you know, we have 2 chlorine here, chlorine, and we have another chlorine. So one chlorine will come here, it will take away one nitrogen. That is, one chlorine will come here, one nitrogen will then, let's assume this chlorine now come here. So one hydrogen will have to leave here and join with this, okay? So if this chlorine join this one now, we have CH, one hydrogen will leave. The hydrogen that is here becomes 3, and this chlorine will now join Cn. That hydrogen that left this place will merge with this, which will now have CHCN. This is what we arrive at. Now, what happens is that in alkane, halogen, one halogen will come and it will replace one hydrogen. So this 2 here is also your value of hydrogen, because it's also a number of hydrogen, because when you multiply your n, maybe your n is 1, multiply with this 2, you still need to add this 2. So this 2 is also part of the hydrogen. So when you are reacting this hydrogen, and what is it called, this alkane formula with an halogen, take the halogen to be X. So this halogen will come, it will replace one hydrogen. Now when it replaces one hydrogen, when it replaces one hydrogen, this 2 becomes 1. So it will be CnH2n plus 1, and it will then join. This a formula of alkane. That was how I explained earlier. This one comes, it replaces one hydrogen. That is, suppose that you now use n is equals to 1 to be, this will now be what? C, 1 times 2 will be what? 1 times, sorry, we are using this. C, 1 times 2 will be 2 plus 1, that will be what? 3. That is CH3 X. And your X here represents what? Your chlorine. You can see it represents your chlorine. So that is formula for alkane. That is formula for alkane. This is the formula for alkane. Please take note of that. It will replace, out of the 2 hydrogen, you know, we have many hydrogen here, but this 2 is also an hydrogen. So it will just replace 1. You are now left with 1 here. So that one, you then add it with whatever this value gives you. Okay? So that is the formula. And the correct option to that is option, it's not minus, so it is plus. The correct answer to that is option D. They even told us that X represents the halogen. Yes, it represents the halogen. All right. Now, for question number 4, consecutive members of alkynes homologous series are differ by what? This is not only alkynes. It's also applicable to alkenes. Members, for example, now, if you have alkane, give me the first 2 in alkane. We have methane, CH4. That is when your N is equals to 1. When you substitute 1 or into the formula of alkane, you have this. When your N is equals to 2, you have C2H6. Now, this is the first 2 members. Now, they are differ by CH2. Take note. Why? Why is it that CH2? We have, let's subtract this from this. Let's subtract this from this. Let's subtract this one from this. We have 2 carbon here and 1 carbon. 2 minus 1, you know we have 2 carbons that are present here. When you subtract this 1 carbon from it, you are still left with 1 carbon. We have 6 hydrogen and 4 hydrogen. When you subtract 4 from 6, you have what? 2. So they are differ. Even in alkyne, in alkyne, all of them. In alkyne, let's assume we have, the formula for alkyne now. The formula of alkyne is this: CnH2n minus 2. This is the formula of alkyne I showed you earlier. So let's assume our Ne here now. Let's take our Ne to be 2. Let's assume we take our Ne to be 2. We have C2H, 2 times 2, that is what? 4. Okay, minus 2, that is what? 2. But let's now assume that our Ne is equal to 3. We then have C3. This is called ethyne. Take note of that. This is called ethyne. So we have C3H. 2 times 3 will be what? 6 minus 2, that is what? 4. So let's subtract them together. Let's subtract this and this. We have C3 and C2. C3 minus C2. That is 3 minus 2. It will still give us what? 1. That is C1. And C1 is same thing as C. 4 hydrogen minus 2 hydrogen is 2. So each of those members are differ by CH2. At times you may not see CH2. You could also see it as 14. You could see numbers like 14, 12, 10 or 8. They are also the same thing as, you see that CH2 or 14. Why is it 14? Because CH2 is the same thing as 14. Why? Carbon has a mass number of what? 12. Plus hydrogen, we have 1 hydrogen. Hydrogen has a mass number of 1. 1 times 2, because we have 2 hydrogen here. That would be 2. That is 12 plus 2. That will give us what? 14. So you could see 14 in your exam. Please take note of that. CH2 or 14. Each members are differ. Each consecutive member, that is the way they follow each other, they are differ by CH2 or 14. So the correct answer to question number 4 is option C. All right. For question number 5, I explained earlier. You can see this question number 5 now is talking about alkanoic acid. And I told you that alkanoic has a functional group of COOH. But how will you identify the correct one? Let me just bring out the correct one and explain to you. Now, we have RC. Now, first of all, you need to know that, the correct one is this. There must be OH here. Yeah, there must be OH. This is how you see it, because OH usually have something like 1 electron. They need 1 electron. So you see it like this. This is the correct one you see. This is the correct one you see. There must be OH here. Take note of that. There must be OH. So that will be COOH. COOH. Sorry for that. Okay, I'm sorry for that. There must be OH. Okay, take note. So that is the correct answer. The correct answer is option B, it's option B, not option C. Please take note of that. There must be OH here because it has 2 oxygen. You could see it here, 2 oxygen. All right. We have another one to be this. Now we have another one to be this. So the question you're asking for the above compound is what? We have H2N, CH2. You see C like this. OH. Is it? They are asking us, they want to know how many functional groups does it have. Is it mono or bi or tri? How many functional groups does this compound have? Now, this is one functional group. H2N. H2N, you can also write it as NH2. NH2 from the, what's it called? Amine. In some cases, you call it amine. In some cases, you call it amino. Okay? So, this is one functional group. And we have another functional group, which is this. The functional group, exactly like this. That is COOH. Okay? COH. So it has 2 functional groups. So we call it bifunctional group. Bi means what? 2. Bifunctional group. Okay? Another question, and the correct answer to that is option C. Option C. Another question we have, how many questions are total? That is 6 questions. Now we have another one to be, which of the following is an aromatic compound? Aromatic, for example, benzene. Benzene has the formula of 6H6. That is, the hydrogen and the carbon, they are the same thing, the same numbers. 6 hydrogen, 6 carbons. Okay. Now, looking at this option A, can the carbon be 6 and hydrogen 14? Wrong. Option A is wrong. Option C, in fact, option C is having six carbons and like 13 hydrogen remaining. After you replace it with chlorine, no, it can never up to 13. It's supposed to be when we have 6 hydrogen and you replace and substituted chlorine, the hydrogen is supposed to reduce to like 5, not 13. You understand? So option C is wrong. Option D is wrong. Option B is correct answer. Why? Because when you have 6 hydrogen and you react with it chlorine, you know, I told you earlier that benzene can also undergo both substitution and addition. So when this chlorine comes, it will replace one hydrogen here, and when it replaces one hydrogen, we have C6H. The hydrogen will become 5Cl. When one chlorine join, the remaining hydrogen will then join with the remaining chlorine, which will be HCl. Okay, so the correct answer to that question is option B. Option B. So how many questions we have done all together? That is 7 questions. Okay. So another one we have here is homologous have the same what? They have the same general formula. Why? Because when you are dealing with members of alkanes, for example, ethane, propane, like the way I was deriving each formula. For example, we have CH4. It's the same formula you used to get CH4. You used to get what? CH4 is called methane, butane, pentane, C3H8. Now, when you put your N equals to 1, you will get this. When your N equals to 2, you get this. When your N equals to 3, you get this. They have the same general formula. And not only alkane, even alkanes, when you use the same formula to get all the members of alkanes using alkanes formula. You know, alkanes has its own formula, so you use its own formula to get all the members of alkanes. Alkynes, use the formula of alkynes, which is this, to get all the members of alkynes, e.g. ethyne, propyne, butyne, like that. You use the same formula to get all the members. So the correct answer to that is that they have the same general formula. Okay, let's look at another question. Now, looking at this question now, we have the pair of compound that belongs to the same homologous series is, they are telling you that which of these two pairs belong to the same homologous series. Maybe do they belong to alkane or alkane or alkyne. So you don't need to start wasting your time there. Now you will see that the correct answer to that, let me just go straight to the correct one. Option A is the correct one. Why? Because from the formula of alkenes, we said alkenes has what? CnH2n. So when I put using option A is the correct answer, as I've said. Using my N now, from option A we have C3H6 and C4H8. So let's assume my N is equals to 3. So I will have C3H, 2 times 3 will be what? 6. That is correct. If my N is equals to 4, that will be C4H what? 4 times 2 is what? 8. So the correct answer to that is option A. When you try to check for the others, you see that they don't match, they don't tally. Okay, they don't tally. So the correct answer to that is option A. All right, let's quickly look at the next question. The general formula for alkanoids. Yeah, I've done this in some of my videos. Alkanoids is when you react alkanol and then alkanoic acid together. When you react alkanol and alkanoic acid, you get alkanoids. You get what? Alkanoids. So let me show you one example. When you react ethanoic acid, CH3 COH plus ethanol C2H5OH. When you react them together, you know, when this one breaks, we have positive, we have negative. When this one breaks, we have Yeah, when this one breaks, we have positive, negative. Okay, now this negative now we then merge with this positive here, and this one we then join with this. Okay, so we said like charges they repel, unlike charges attract. So here now when this one merge with this, we have CH3 COO. Now this one we then join it here, we have C2H5 plus two hydrogen. Now this hydrogen will then join with this OH, and the hydrogen becomes two, that is H2O plus the O, which will be what? Oxygen there. All right, this is what we have. So compare that now. Using that to compare this question, the correct answer there is option C. Why? Because this represent ethyl group. This one also represent what is it called? This represent alkyl group, and this one too also alkyl group. This is called ethyl, while this one is called methyl. That is why you see that they represent this one, because they represent this one with what? R and COO. R. This is their ethyl and with their alkyl group. So the correct answer to that is option C. Option C. All right. Let's look at the next question. We have one of the characteristics of homologous is they have similar. The correct answer there is similarity in method of preparation. Yes, in Alkane, when we have methane, the same way you prepare methane under Alkane is the same way you prepare ethane, propane, butane. That is the same way you prepare it. And likewise, in alkanes, the same way you prepare ethene is the same way you prepare propane, butane, like that. And the same thing applicable to alkyne. The same way you prepare ethane, that is the same way you prepare propane, like that. So they have the same method of what? Preparation, but their physical method this thing are different. They are different physically. Why? Because if you look at from the formula of what is it called? Alkane. Suppose my Ne is equals to 3. I will have C3H. 3 times 2 will be what? That will be 6. Okay? Plus 2, that will be what? 8. Now, this is called propane. Okay? Or let me change it to be butane now. If my N is equals to 4, I will have C4 H what? 4 times 2, 8 plus 2, that is what? 10. This is butane, the one we use to cook at home, butane. Okay? Now, let's assume my N is equals to 8. So I will have C8 H. 8 times 2 is what? 16 plus 2, that is what? 18. This is called what? This is called octane. Now, octane is also known as petrol. Okay, it's the formula of petrol. It's petrol, the petrol you use for your, what is it called? Vehicle. So this one is called butane, the one used to cook at home. Now, when you look at it, try to get petrol on one side and butane on one side. Butane is the gas. Everything is gas, but petrol is liquid. And even though when you go down, you still have diesel. Like when you start getting to, you have kerosene, you have diesel. By the time you start getting to C15 H32, start to have kerosene, diesel. Are those ones, kerosene, diesel, petrol, they are still under alkanes. They are members of alkanes. But are they the same physically? Some are liquid, some are what? Gas. Diesel is liquid. In fact, it's highly viscous liquid. It has a high viscous liquid. Okay, and petrol liquid, kerosene liquid. So they are not the same physically. And butane, the one you use to cook gas, can you say you want to pour butane on cup? Everything we escape. So that one is gas. So physically they are not the same. Take note of that. They are not the same, but they all have the same formula. What is it called? The same general formula. For all alkanes, they have the same general formula. All alkanes, they have their own also general formula, and I've explained that at the beginning of this video. Even all alkynes, they have their own formula. It's the same formula you apply for all the alkyne family. Okay, all right. So the correct answer to that question is they have similar method of preparations. Yeah. And that is option D. Okay, for the next one, let me check. So the next one we have here is the four main classes of hydrocarbons are the four main classes of hydrocarbons are, you know, all those cycloalkanes, they are just like cycle form of alkanes and cycle form of alkenes. But the four main one we have are alkynes, and the aromatic. You know, the aromatic at the beginning of the what's it called? At the beginning of the video, aromatic has gone on its own way. So that aliphatic, we just try to break it that okay, in this aliphatic, we have some that are just like circle, while some that are like either branch or straight chain. Okay. Alkane, they are like branch or straight chain, and the cycloform of alkanes. So those ones, they are not like main classes. The main classes are alkynes, and the aromatic. Okay. And the correct answer to that is option D. Take note of that. Let me check the next question we have here. So the next question we have is, which of the following tests can be used to distinguish alkanes from aliphatic hydrocarbons? How do you differentiate alkanes? What's it called? Differentiate aromatic from aliphatic is due to the way they burn in air. Why? Because aromatic, they burn with a sooty flame. But you see, alkane, when they don't burn with a sooty flame. But actually, alkanes and alkynes, they burn with a little sooty flame, just little. But aromatic is very much, very plenty. So what differentiates them is the way they burn in air. Okay, alkane, they don't have, but alkanes and alkyne, because they have 2 or 3 bonds, so they burn with just little sooty flame. But aromatic, they burn with a very high sooty flame. Okay, so it's the way they burn that distinguish them. Please take note of that. Okay, and the next question we have is now both both addition reaction and substitution reaction can be undergone by, I've explained this earlier, benzene undergo both addition and substitution reaction. But the thing is that, why is it that benzene undergo both? You know, benzene undergo substitution reaction because even benzene prefers substitution reaction, because substitution reaction, it does not spoil the benzene ring. That benzene ring, it does not spoil it. Let me show you. You know, benzene ring, it does not spoil the benzene ring. Okay, that is why benzene prefers substitution reaction, because it does not spoil the ring, while addition reaction spoil that benzene ring. Take note of that. Okay, all right, our next question is, okay, which of the following gas does not decolorize bromine water? Now, this is one of the way you differentiate them. You see, alkane, you know, it has single bond. It is called saturated compound. And alkynes and also benzene also have double bond. Those ones, they are called unsaturated compound. I explained that at the beginning of this video. So you see, those ones that are saturated, they don't decolorize bromine water, like alkanes and the cycloform of what? Alkanes, because alkanes has single bond and cycloform of alkanes also has single bond. Those ones, they don't decolorize bromine water. But you see, the alkynes, they have double bond, triple bond, and even benzene also have. You can see that benzene has double bond at times. Okay, benzene has double bond. Okay, so benzene, they decolorize bromine. All those benzenes, alkenes, and they decolorize bromine water. So what this question is trying to tell us is that, which of the following does not decolorize bromine water? It is alkane. So look for member of alkane here. Which members of alkane? Which one is members of what? Alkane. If you test them with that formula one after the other, the member of alkane here is option D. Why? Because using the formula of alkane, this is formula of alkane. Our N is equals to 4. We have C4, H 4 times 2, 8 plus 2, that is 10, H10. But if you test others, they will not give you the same thing there. For example, let's test option A. Option A, now we know we have C3, We have C3H6. So let's assume our N is equal to 3. That will be C3H. 2 times 3, that is what? 6. Plus 2, that is what? 8. Supposed to be 8, not 6. So it's not an alkane. Take note. And the same thing applicable to the rest. But the correct one is option D. Option D. Okay, and I hope this class is getting more interesting. Okay, let's look at the next question we have. So the next question we have now, we said ethene produce less soot than benzene on burning because ethene dash. I explained that unsaturated compound like ethene, ethane, and benzene, they burn with a sooty flame. But benzene is very massive. But you see, ethene and ethane is just little, especially ethene, very little, because it's born with a, what's it called? Because of its double bond. Double bond is very little. Triple bond is still more than that one. But benzene is very high. Okay, so what this question is trying to tell us is that ethene produce less sooty flame on burning because of what? Because of its B. The correct answer is B. Why? Because it has low degree of unsaturations. When you talk about unsaturated, unsaturated are those that have like 2 or 3 bond and above. So like 18 is the lowest. So because of its lowest, it's as little. But ethane now still has triple bond. That one is more than 18. So it's on the way it burn, the sooty flame of ethane is still more than what's it called? It's still more than it's still more than 18. Okay. So because of it has a low degree of unsaturated, is the least. Okay, take note of that. Take note, alkane is not unsaturated, it's saturated, but that's for that. All right, let's go to the next question. Now to this question now says the reaction between alkanol and ethanoic acid in the presence of acid catalyst is known as. Now that was the same thing I explained. Ethanol, this is telling us the reaction of alkanoic acid and alkanol. Now this is an example of alkanol and this is an example of alkanoic acid. Okay, ethanol is an example of alkanol, while ethanoic what's it called? Ethanoic acid. Sorry, ethanol is an example of alkanol, while ethanoic acid is an example of alkanoic. Now when you react them together, it will form this. You remember earlier, CH3. Let me try to erase it so you could see it properly. So it will form what we call CH3, CO, C2, H5. Now, this type of reaction is called, they are asking us, what is the name called? What is the name called? The name of this reaction is called esterification reaction. It is called esterification reaction. This product is called ester and water. That is, when this and this react together, alkanoic and alkanol, it gives us ester and water. Ester and water. So, but the name of the reaction entirely is called esterification reaction. Please take note of that. And the correct answer there is what? Option C. Option C. All right, let's look at the next question. Which of the following is a polymer? The correct answer is option C. Why? Benzene is a polymer because when many ethane, when you have many molecules of ethynes come together, polymerization simply means multiples. When we have monomers joining together to form a larger one, it's called polymerization. Okay, so when many ethyne molecule, when they began to join together, they form a larger one, and the larger one they form is called benzene. It's called what? Benzene. And you look at the following option, they represented them benzene in its structural form, and the structural form of benzene is this. Don't worry the way it is being done there. What matters is the size as 6. 1, 2, 3, 4, 5, 6. And you can put one bond there, leave this one, put it here, leave this one, put it here. So, or if I don't want to start like this, you can also do it like this. You can put it here, Now I started like this. I started here. You can put it here, leave this one, put it here, leave this one, put it. The rule is that what the rules tells us is that when you put it on one, leave the other one. Put it on the other, put it on this one, leave the other one, put it here. You must not put two together here. Don't do it like that. So it is benzene. They just represented it in its structural form, and that is the structural form of benzene. Option C is the structure of what? Benzene. That is structure of benzene. And so the next one we have here is what's it called? Now we have it when an alkanol is heated with excess H2SO4, an alkanol is dashed. Now when you react alkanol, for example, what is the example of alkanol? Take this ethanol as an example. I usually like to use this ethanol, and it's very common in the textbook itself. So when you have C2H5OH, when you react with its excess H2SO4, that means that one simply represent serve as catalyst. That H2SO4 serve as catalyst. What that H2SO4 will do is that, what we are trying to do in this kind of reaction is to remove H2O from this compound. When you remove H2O, we have OH here. When you remove OH, H2O has what? H2O is water, 2 hydrogen and 1 oxygen. Now you have removed 1 oxygen has gone. You have removed 1 hydrogen. You still need to remove 1 more hydrogen to make it complete 2 hydrogen. So when you remove that 1 more hydrogen, the hydrogen will have to leave here. When this hydrogen leave, we are now left with 4 hydrogen here and 2 carbons. So this will give us C2H4. Now plus that 1 hydrogen that join with this, it will form H2O. Now what we are trying to do is that when you heat this, that H2SO4 serve as catalyst here to dehydrate, to remove that water. So when you remove it, this is also called dehydration. Please take note. So when you remove it, it forms what you call, an example of what? Alkanes. From the formula of alkanes, is what? CnH2n. So suppose our N is equals to 2, we have C2H what? 2 times 2, that will be 4. You see that it's exactly the same thing as it. So it's a member of alkanes. It's dehydrated. Yeah, it dehydrated to what? Alkanes. The reaction is called dehydration because you remove H2O. That is what I explained earlier. You remove what? H2O. And when you remove H2O, it is called dehydration reaction. So the correct answer is what? It's not reduction. We are not dealing with oxidation reduction. Sorry for that. We are not dealing with oxidation reduction. It dehydrates. It remove that water. Removing water means dehydrate. That is dehydration. It dehydrates what? Alkanes. It dehydrates to alkanes. And the correct answer to that is option C. Option C. Next question we have here is now which of the following alkanes has the highest boiling point? You see, one thing is that when you start going down from the family of alkanes, this is the formula of alkanes. When you put your N to be 1, you will have what you call methane. When your N is equals to 2, you have what you call what it will give is called ethane. When your N is equals to 3, it will have what? Propane. When your N is equals to 4, you have butane. When your N is equals to 5, you have pentane. When your N is equals to 6, you have hexane. When your N is equals to 7, you have heptane. When it is equals to 6, it's called hexane. When it is equals to 7, it's called heptane. So now, if you're going down like that, as you are going down, the more the boiling point begin to do what? Increase. So the correct answer is heptane. Heptane. For the first one, propane, that is when your N is equals to what? 3. And B, pentane, when your N is equals to 5. And option C, that hexane, that is when your N is equals to what? 6. And option D is what? Heptane, that is when your N is equals to what? When your N is equals to 7. So it has the highest boiling point. Heptane. Option D is the correct answer. See, just think. When you bring a petrol and a diesel, which one do you think has a highest boiling point? If you want to boil them, which one do you think it will boil faster and begin to evaporate? I'm not saying you should try it though. Don't go and pour petrol on pots and say you want to boil petrol. As an example, if you want to boil it, which one do you think it will easily boil faster? Petrol will boil faster since, but you see, diesel, it need to start breaking all those bond, all those covalent, all those what's it called, all those bond that join them together before that one with it has a what's it called, a its boiling point is much more than petrol. Okay, so the more you go down, the more their boiling point do what? Increase. Take note of that. All right, so the next question we have, so for that one is heptane. Okay, that is option D. So the next question we have is this one says, when a heavy fraction from petroleum is heated at high temperature, a lower liquid is obtained. The process is known as, when you are trying to heat a heavy fraction of petrol, that is, you are trying to, when you have a heavy fraction of petrol, as an example, suppose you bring diesel, and maybe when you check economic demand, notice that in Nigeria or in most of this country, you will demand petrol than, that is, we consume a lot of petrol than use diesel. Okay, how many people that are using diesel in your society are compared to people that are using petrol? You use petrol for vehicle, for generator, for a lot of things. So we demand petrol, much more petrol than diesel. Or even talk of butane, cooking gas, we demand much cooking gas than diesel. How many people that are using cooking gas in your place? Almost everybody. But how many people that are using diesel? So for that, we need, let's assume you separate your crude oil and you have diesel. So we don't really demand much diesel. So you can take heavy fractions like all those diesels and all those heavy fractions. You try to break them. You try to break them down so that you can get all those ones that are demandable. Those ones like butane, like petrol, those ones that we usually use mostly. You try to get them from those heavy fractions by breaking them down. And the process of breaking them down is what we call, what? Cracking. By breaking down of all those larger molecules, those larger ones, to get those simple ones that we usually use, that are usually demandable in around us. Okay, so that process is called cracking. Okay, the correct answer to that is option C. Cracking. Take note of that. Okay, take note of that. And the next question we have here is the reaction between ethanoic acid and potassium hydroxide. Illustrate dash. Now, ethanoic acid, let's erase the board. Ethanoic acid, let me erase here. Ethanoic acid, example of this is ethanoic acid, CH3 COOH plus, and potassium hydroxide, this potassium hydroxide. So this reaction give us what? When this one breaks, we have positive, we have negative. When this one breaks, we have, what's it called? Negative, positive. So this negative will match with this positive. That will be CH3COOK plus this one we join with the remaining OH here to form H2O. Now, this reaction is called, this is a base. Potassium hydroxide is a base. Another name for base, you know, we have soluble base and insoluble base. But another name for that base, another name, because this is a soluble base, another name for base is called what? Have you forgot? Don't forget your acid, base, and salt. Please drop that in the comments. Okay. Now, this is a base, why this is acid. But the thing is that this is a strong base, why this is a weak acid. Okay. But it is still a reaction of acid and base. So that kind of reaction is called, it's not esterification. This one is called esterification. Why this one is called what? Neutralization. Neutralization is the reaction between acid and base. Why esterification is the reaction between alkanoic and what? Alkanol. Okay, that is the difference. Take note of that. Yeah, the correct answer is option B, neutralization reaction. Neutralization what? Reaction. Okay, so the next question we have is, now substitution reaction is represented by, substitution reaction is represented by what is substitution reaction? I said alkanes and only benzene, they undergo substitution reaction. Alkanes and the cycloform of alkanes, and even benzene also undergo substitution reaction. So we are dealing with the reaction between alkanes and halogen, like chlorine or bromine. Now let's look at the question. Now in this case now, when you talk about substitution reaction, I just want to go straight to the now if you look at option B, methane and oxygen, that is not substitution reaction, that is called that one is called combustion. As is methane bond with oxygen, bond in air. Okay, but when you look at option C, that C3H8 is a member of alkane. But when you look at option A, C2H4 is not an alkane. It is a member of alkenes, not alkanes. So option A is wrong. And alkenes does not undergo substitution reaction. Please take note. Be wise. Option B, CH4 is actually alkane, but it's reacting with oxygen. That is not substitution reaction. That one is called combustion. So option B is wrong. Option C, C3H8, that is an alkane. Reacting with chlorine, that is halogen, right? That is example of substitution reaction. So that is the correct one, but I will explain to you. So option D, C2H2, that is alkyne. Please be very wise. That is why knowing the formula is very important. So that is an alkyne, and it's also reacting with hydrogen. It's also wrong. That is not substitution reaction. Substitution reaction is when maybe alkane is reacting with halogen, like chlorine or bromine. But option A would have been correct. It would have been substitution reaction, but because that compound that is reacting with bromine is not an alkane, it is an alkene. So option C is the correct answer, and I've explained what substitution reaction many times. Okay, so that I said the compound we have here is C3H8 plus Cl, and when you react this and this together, Cl2, one chlorine will join and one hydrogen will leave here, join with the remaining chlorine. You know, we have two chlorine here. When one chlorine join, you have C3, you have C3H, each instead of 8, it will be what? 7. And that chlorine that left here will then join. So plus, we still have one chlorine left because there are two. One have joined. That one hydrogen that left here will then join with the remaining chlorine that is left. It gives us this. So you can see that option C is correct. Option C is the correct answer. Okay, please, I know this class is getting more interesting. Please, like, comment and share with your friends. Okay, comment and share. Okay, now you can see that the remaining parts now, this is mainly organic, what's it called, names of organic compound, the IUPAC names. Actually, I want you to know that I did a lot of videos on how to name organic compound. So you watching this one alone is not enough for you. In terms of, I'm talking about names particular. I've done many videos, when I say many, on my channel. Check my channel and watch them. If you have any questions, drop it in the comments. I know that if you watch it, it will impact you. Okay, so this remaining parts now, this with naming, and this naming I'm doing now is those ones that I've not yet done on the other videos. This that particular naming that we are dealing with now. Okay, now looking at this, that is, I think this is our we have done 22 questions. So these are our 23 questions. 23, 24, 25, 26, 27, and we are going to, we still have 2 more. Okay, so for that we have sorry, so now if you look at this properly, now we have what we call substituents, which is this, and we have this double bond that is here. So when you want to name this, you have to take note of those 2 things very well. First of all, let's get the parent's name. What do you think the parent's name will be? Or first of all, let's write out the substituent. So we have methyl. We have methyl CH3, which is methyl, and we have double bond. Now we have gotten that. So let's get the parent's name. 1, 2, 3, 4, 5, 6. I think that is the longest carbon. First of all, if you want to name, you have to look at the longest carbon chain. So when you go like this one, when you go in this direction, you can rather go like this or like this. 1 2 3 4 5 6, or let's assume I come like this. 1 2 3 4 5 6. This is the longest chain. The first one is still the same to 6, but let's do this with this one to make it easier for us. Now the thing is that I can start to number those carbons as carbon 1, carbon 2, carbon 3, carbon 4, carbon 5 to carbon 6, or I can rather start here 1 2 3 4 5 6. What matters, what determines where to start is this double bond. Actually, if there is no double bond, what determines will be this. But because this double bond now, it has a higher priority than this methyl, so we must do it on the favor of this double bond. And now if I'm to go like this, I will need to count 1 2 3 4 carbons before I get to this double bond. But what if I come like this? 1 2, just 2 carbons have gotten to the double bond. Which one do you think is more faster? Coming like this. So we then, because so we prioritize the shortest one, that is from here. So we start to number the carbon like carbon 1 2 3 4 5 6. So by the time you want to start numbering, you need to take note of the parent's name. The parent's name will be, since it is double bond, that is from alkanes, that is right, alkanes. And which alkanes has how many carbons all total? 6 carbons. So which alkanes member has 6 carbon? You know, if it is alkane, that 6 carbon, that should be 6 H or H14, right? And that is azane. So in alkanes now, we don't call it azane. We call it what? We call it what? Azine. We call it what? Azine. We call it azine. But because of this double bond, where is this double bond located? 1 2. It's after the second carbon. The second carbon, right? So we then call it S2 because it is located at the second carbon. 1 2. It is after the second carbon that you get to this double bond. So because of that, you call it as what? S2. It's still the same thing. I just put 2 here, telling us that the double bond is located. It's like this. You know, initially I wrote azine. So this NENE, HEX. So we put this 2 here to tell us that the double bond is after the second carbon. Okay, so because of that, we'll be using this one as our parent's name. It's still the same thing, okay? But we're using this one as our parent's name. All right, so if you want to name this one now, you start to number from this. This one it tells us the parent's name. But the only substituent we have is this. It's called methyl, but this methyl is located at the 5th carbon. So we say 5 methyl. So is there any other substituent again? No. This determines the parent name, but the parent name is what? S2. So we just write it as 2. That's just it. And the correct answer to that one is S4. No, it's wrong. The correct answer is option B, S2. Option B is the correct answer. Please, you can't see that option B and C, they are almost the same thing. They are trying to tell you that, let's assume you start numbering here, it would have been at the 4th carbon. If it happens at the 4th carbon, it would have been S4. So that's why you have to be very careful. You must start on the favor of this, the shortest one. If you come like this, after 2 carbon, you have got it to the, but if you are coming like this, it's after 4. So, but this one is the shortest one. So please take note, you must start from the shortest one, okay? And let's look at the second one now. The second one here, sorry, here is bromo. We have bromo here. Br. Yes, Br is there. So if you have to name this now, you need to take how many, does it have substituent? Yes, this is substituent. Write it out. We have bromine. So you don't call it bromine, you call it what? You call it bromo. Now, where am I going to start numbering? Now, does it have, okay, where am I going to start numbering? Will I start numbering from here or from here? But now take note that this double bond has higher priority than this bromine. So we must do it in the favor of this double bond, not bromine. So if I start numbering 1 2 3, I need to count 3 carbons before I get to this double bond. But what if I come like this, 1 2, just 2 carbons before I get to this? So this one is more faster. Then we go with this. So we say this is carbon 1, carbon 2, 3, 4, 5. Now, after getting that bromine, what will now be the parent name? The parent name will now be what? Now this double bond tells us the parent name, that is from the family of alkanes. Alkanes. So how many carbons all total? 5 carbons. So which member of alkanes has 5 carbons? That is pentene. You know it is pentene. It is pentene. Now you can write this pentene as pent. Now because this double bond it tells us that it is from the family of alkanes, but this double bond is where? It's after the second carbon. 1 2, it is after the second carbon. So I can write, I will put it as pentene. This 2 here tells us where the double bond is. Okay, you see that pent ene is still the same thing. The only thing, the difference is these two. Tells us that the double bond is after the second carbon. Okay, so this will be the parent name. We take this to be the parent name, and this is the substituent. So if you want to start naming, we have bromo. You start from the substituent, and this bromo is at what? Carbon 2. So we say that 2-bromo what? We don't have any substituent again. Then join the parent name with it, and the parent name is what? Pentene. That is our final answer to that. That is option B. Option B. So the correct answer to that is option B. Option B. Okay, let's look at the next question. Now for this, you don't need to stress yourself much. Now this tells us the parent's name to be what? To be alkyne, right? To be alkyne. Okay, but which alkyne has, this one does not have any substituent, so let's name direct. Which alkyne members has 4 carbons? I think it's 4 carbons all total. 1 2 3 4. It's 4 carbons. Even though if it come like this 1 2, it is after the second carbon you get to this triple bond. Even though if it come like this 1 2, it is still after the second carbon. So you can pick anyone. So now, which member of alkyne has 4 carbon? It is butyl. Butyl. Okay, that is butyl. But now, if I number like this or like this, since both of them is at carbon 2, that is after the first 2 carbon you get to this, and if you come like this, after the first 2 you get to this. So pick one. Let's assume I pick this one, carbon 2, carbon 3, carbon 4. Actually, we only have the parent's name. The parent name is butyl, but we just want to identify, we just want us to know where the double bond is. So the double bond is after the second carbon. So we can also rewrite it as but 2I. And that is our answer. That is our answer. But 2I. That is option D. That is option D. That is option D. So let's name this. Let's name this. The correct answer to this is option D. Let's name this as the next question. Now, naming this, you know that what takes the higher priority here is this double bond. That is first thing. You have already took note of that. Okay? Take note of that. So since this take the higher priority, then if you count like this 1 2 3 carbons before you get to double bond. But what if you count like this 1 2 3 4 5? So sorry, 1 2 3 4. Yeah, coming like this will be better. Yeah, coming like this will be better. So we say this will be 1, carbon 2, carbon 3, carbon 4. Does it have any substituent? Yes, it has substituent. What's the name of the substituent? This is substituent. It is called what? Ethyl. This can also be written as how many carbons? 2 carbons and 5 hydrogen. That is C2H5. So it is called what? It is called ethyl. Okay. Now, since you already know the substituents to be ethyl, then what will be the parent name? Which, you know, this tells us the parent name. This double bond there tells us the parent name. So that is from the family of what? Alkane. Alkane has double bond. So which member of alkane has 4 carbons? That is C4. That will be C4H H8, and that is what that is butene, right? So the parent name will be butene. But if you want to further break it, the The double bond is located to which carbon? It's after the first carbon. So we can write it as but one in. Now to name this let's erase this. So to name it now, we say what? We start from the substituent. The substituent is this. It's located at what carbon? Second carbon. We say 2-ethyl. 2-ethyl. Do you have any substituent again? No. Benzene. Then attach the parent name to it. 2-ethyl. What's it called? Butene. I mean, sorry, 2-ethyl. But one in. 2-ethyl. But one in. This is our correct answer. That's our correct answer. And then which option is that? The correct answer there is option D. Option D is the correct answer. Option D is the correct answer. So let's name this before we erase the board. So to name that, now this one is for this. Take note. This is for this. That is, this place doesn't contain it, and we wrote it here. Okay. So let's name this. To name this now, we can further rewrite this as this: CH3, CH2, CH2, C, double bond C. We can write it as this: CH3. This CH3, I just brought it at the top here. Why this CH3? I want to put it here. CH3. Why this one still remain under here? So if you want to name this one now, you must make sure that double bond, it has substituent, right? And it has two substituents, but the two substituents, they are the same. Methyl. So the substituent we have here is methyl. We have methyl, that is CH3, which is called methyl. And then, but to start numbering the carbons, you must do it in the favor of this double bond. If I come like this, carbon 1, 2, 3, 4. It is after 4 carbon before I get to this double bond. But what if I come like this? 1, 2, 3. 1, 2. It is after the second carbon before I get to this. So this one is very fast. I will pick this. So this will be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. All right. So what will be the parent name? First of all, this double bond tells us the parent name from the family of alkanes. And which alkanes member has 6 carbons? And that is C6H what? H12. And that is what? Acing. That is acing. And acing, we write it as where the double bond is located after the second carbon. Because it is located after the second carbon, we call it as 2-in. The only difference is just these two. HES, ENE, ENE. Just these two, which tells us that it is after the second carbon. So this, we take the parent's name. You know, it's simplified. It tells us better than this. Okay. Now, to name this now, we say, if you are coming like this, you get to first methyl here, and the second methyl is here. So the first methyl is at carbon 2. The second one is at what? Carbon 3. So we say 2, 3. Now, how many methyl? It is 2 methyl. Dimethyl. We call it dimethyl. Do we have any other substituent again? No. As attach the parent name to it. As 2-in. As 2-in. So that is our answer. And the correct answer to that is 2,3-dimethyl as 2-in. That is option D. Option D. Option D. Option D is the correct answer. Okay. Now we have done 27 questions already. Okay. So we are left with 3 questions to make it complete 30 questions. Okay. So now this is 28, 29, 30. All right. Let's name the 28th. Now to name this, first of all, you can rewrite this as, take note, you can write this C2H5 here. You can write it as CH3, CH2. Why? Because two carbons, 5 hydrogen. 3 plus 2 is 5. So you can write it as this. Don't be confused, okay? Now this exam they are just to test whether you understand it or not. So if you have to name this now, first of all, check the longest carbon chain. 1, 2, 3, 4, 5. That is, I can rewrite this as this. I can also write this as this. I can decide to bring it here. I can decide to write this and put the hydrogen on top and put this one like this. You know it is CH3, so I can decide to write it like this. Okay, I can decide to bring the hydrogen here on top and bring this one here. It's still the same thing. Okay, so don't be confused. That is 1, 2 carbons, 3, 4, 5. 1, 2, 3, 4, 5. Okay, now I did it like this to make it easier for you to know that we have only one substituent, which is this. I can, if I come like this, 1, 2, 3, 4, 5. This is the only substituent we have. So if I want to start number, I can start like this, number like this, or like this. Still the same thing. So I just try to bring this one here, bring this hydrogen on top. It's still the same thing. All right. So to start naming now, you have to do it in the favor of this double bond, because this double bond has higher priority than this CH3. So am I to start like this or like this? 1, 2, 3. I need to count 3 carbons before I get to this double bond. But what if I come like this? 1, 2. I will just count 2 carbon atoms before I get to this double bond. That is 1, 2 before you get to the double bond. So let's choose this shorter one. Is the best one that we must follow. It is that shorter one that we must follow. This will be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So if you want to start naming, the substituent we have CH3. CH3 is called what? Methyl. It is called methyl. Sorry. It is called methyl. And then, so what will be the parent name? This determines the parent name. Double bond tells us that it is an alkene member. So which alkene member has 5 carbons? 5 carbons. That is pentene, right? Pentene. So we can break this one further by saying, now this pentene, now the double bond is attached to what carbon? This carbon 1, carbon 2 is attached to carbon 2. So we can just put the 2 at the middle here to be what? Pentene. In PNT. So the bond is after the carbon 2. Okay. Now to name this, now we start from the substituent methyl, but this methyl is attached to what carbon? Carbon 3. So we say 3 methyl. That's the only substituent we have. Then join it with the parent name, pentene. That is our answer. And the correct option to that is option what? Option A. Option A. 3-methyl-pentene. Yes, 3-methyl-pentene. Okay. So let's name this. To name this, I need to break this one further for you to understand. So let's write it out. We have CH3. I can also write it as CH3. I can put one single bond there. It's still the same thing. CH. Put the double bond there. C. Now you pick the longest carbon chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now I would advise that we use it because of this chlorine here is attached to this. This chlorine is attached to this. Take note. It is attached to this carbon. So let's choose this one. So let's choose this one. And when we choose this one, this one will now be the substituent. It will form on top, which will be something like this. Let's take this C to be this C. So I want to bring this one on top, which will be, now bringing it on top, I will have CH2. I can also write as CH2, CH3. Now, this CH2 and this CH3, they are the one here. This carbon is this. So this one, I just want to write it like this, which will be CH2. Or I can rewrite it as this. These 2 hydrogen are attached to this carbon. I can put one hydrogen on top, put one hydrogen at the down. And this CH2, this carbon is this now. This carbon is this. Join with two hydrogens, one on top, one on down, and this one then join with this. That is, I can put it as hydrogen, hydrogen, and chlorine here. But I can also decide to change it by putting this chlorine here. It's still the same thing. I can put this chlorine here and put this hydrogen here. I can decide to do it like that. Sorry, I said earlier that it has this substituent. No, chlorine is also serving as a substituent here. Please take note of that. So now we have how many substituents? These two substituents, this and this. So we have, this is called ethyl, C2, the two carbons and 5 hydrogen. So C2H5 is called what? It is called ethyl. And Cl is called what? Chlorine, and we call it as chloro. Okay, now to start numbering, the double bond determines. Now if I come like this, 1 2, on getting to carbon 2, I will have already reached where the double bond is. But if I come like this, 1 2 3, this one is still takes a longer time, but we follow this shorter one, 1 2. All right, but first of all, what is the parent name? Because of this double bond, it's from a family of alkenes, so that will be 1 2 3 4 5. And then which members of alkenes has 5 carbons? That is pentene, right? Pentene. So I will write pentene. But because I want to identify where the double bond is, since I'm start numbering, I will start numbering like this, as I've explained. 1 2 3 4 5. So it is after carbon 2. Okay, so that will be pent. I'll put the 2 here in between here. Pent 2 in, tells us that it is after carbon 2. So to name this now, we start naming the substituent first. But looking at the substituents, which one do you think will come first? Ethyl and chlorine. Now this is not ethyl and methyl. Now let's assume it is ethyl and methyl. We would have said ethyl has higher priority than methyl. But ethyl and chlorine, now chlorine has higher priority than ethyl. Even though if you check alphabetical order, chlorine C comes first before ethyl now. It comes first before ethyl. So chlorine has higher priority than ethyl. So chlorine will come first. Why naming? So but chlorine is attached to what carbon? Carbon 5. So I will say 5 chloro. Instead, I will call it, instead of me calling it chlorine, I will call it chloro. Followed by ethyl. Well, ethyl is attached to what carbon? Carbon 3. 3 ethyl. Then that we are done with the substituents. So we put the parent name joined, and the parent name is this: pentene. Pentene. So that is our final, that is our answer to that. And which option describe this? Option. Let me check the option. 5 chloro, 3 ethyl pentene. Option C. Option C is the correct answer. Option C is the correct answer to that. So let's answer the last questions. Let's answer the last questions here. For the last questions, so the longest carbon chain, 1 2 3 4 5. So now we don't need to waste our time. We have how many substituents? Just 2 substituents, and the 2 substituents are the same. thing. CH3 is called what? Methyl. In fact, drop the answer of this one in the comments. Just drop it in the comments. I know that you have one way or the other learned a lot of things here in this class. Please don't just go without liking the video, without comments. Please consider to like, comment, and share with your friends. All right, thank you. See you in my next class.